Oh, welcome guys. Uh, okay. So in this video, let's talk about the proof of the normal distribution, the characteristic function and the moment generating function of the normal distribution. Okay, so normal distribution f is divided 1 over square root 2 pi sigma exponential this minus x minus mu squared divided by 2 sigma squared. Okay, and the mu is the mean, sigma is the variance. Okay, so before I start, please subscribe to my channel. Okay, so the integrate formula we will use is that if you have exponential minus x squared plus bx plus c, then you can first do the perfect square, and the final answer will be square root pi over a exponential b squared minus 4ac divided by 4a. Okay, and a should be greater than 0. Okay, so once we prove the moment generating function, then we can plug it to get the characteristic function. Okay, so you just times exponential xt and do the dx, right? So the rest is just doing this. So we just plug in and we expand it. We do it, so we expand it like this. Okay, so you see this guy is not related to x, so we can pull out. So we get this. Okay, so now a is this mu divided by square. A is this first term, right? So it's 1 divided by 2 sigma square, and the b is negative mu divided by sigma square plus t, and the c is 0. Okay, so we can use this formula. Okay, so we can use this formula. So we just use b squared divided by 4a because c is 0. Okay, so we get this divided by 4a. So a is 1 over 2 sigma squared, so it becomes 2 sigma squared, and the square root of pi 2 sigma squared. So you see these two can cancel. So this is final one, right? You just expand it and do the calculation. So you will see the sigma, this first term cancel, the rest is this mu t plus a half sigma squared t squared. So this is a very famous result, I think you should remember. Okay, and you just plug a t to be it, you get I mu t minus a half sigma squared t squared. Okay, so this is the proof detail of the characteristic function, the moment generating function of the normal distribution. Okay, I will see you guys in the next videos.